Hello, everyone, and welcome back to Perceive 2021. Please give a warm welcome to our own Karen Herder, a data strategy manager for Clarifai, who will be speaking about developing data taxonomies for maximum AI-powered experiences. Welcome to our stage.
Hi, everyone. Welcome and thanks for joining. Today, we're going to be talking about developing data taxonomies for maximum AI-powered experiences. So this graphic right here is basically an overview of the entire model creation process. It's a simple kind of visual breakdown to understand each of the steps in the process, from pre-build considerations to post-build model maintenance, which is pretty much everything we'll be talking about today. So what is computer vision? As part of the pre-build process, it's important to just understand what you can do with computer vision. And what is it? It's basically teaching computers to see and classify visual content much like a human can. So think of your computer vision model as a brand new baby who is learning everything about the world for the first time. You are its model parent, and you're responsible for teaching your baby model everything it needs to know about its new world, which you're going to define with your taxonomy, concepts, and training data. So what is a concept? In simplest terms, a concept is something that you want your model to provide predictions on, which leads us directly to training data, because that's what provides the context for the model to understand each concept. Training data is everything your model learns from. It's pretty much impossible to account for every image a model might encounter in the real world. So the goal of training data is to be as diverse as possible. We call this creating a whole world view of each concept. By showing the model as many diverse images as possible, we are teaching it to expect those visual differences within each and every concept. My first week at Clarifai, a machine learning engineer gave me some great advice for working with computer vision. Don't expect a model to see something that your human eye cannot. Another way of saying this is if your eyes can't pick up on, say, like a particular detail in an image, or you couldn't tell the difference between two strikingly similar images, you shouldn't expect a computer to do any better. Computers don't benefit from any context outside of the image, unlike what human brains can do. So the first step here in our pre-build model process is we need to define the model use case and stick to it. It's important that your model matches the use case you intend to use the model for. Because if the training data doesn't match the use case, your model is going to perform poorly because you didn't provide it with accurate examples. Then you need to consider kind of other kind of like parameters, like is there an accuracy threshold that's important to you? Do you value precision or recall more than one or the other? And then will you have enough data? This is kind of one of the many black box type of questions in the field of computer vision, because there's no standard minimum or maximum amount of amount of data that you need to build a model. Data needs can change depending upon many factors, such as use case, taxonomy size, taxonomy complexity, the type of model you end up building, whether that be a context-based classifier or a deep trained model. My favorite guidance to give is, it's a little cliche, but it's tried and true. Always add more data. Even if you think you have enough, you could probably add more. As long as it's new and diverse and very different from what you already have, so you're not overfitting your model, more data is always a good bet to go on. So once you have defined your success criteria, or your model goals, or decided what type of model you're going to build, it's time to define the model taxonomy. And a model taxonomy is just a list of the concepts that make up your machine learning model. And here are some tips for developing your taxonomy. First and foremost, the most important thing to remember when building your taxonomy is that the concept should be visually distinct. This means that each concept looks different from other model concepts. The more visually similar two concepts are, the higher chance of confusion between them in model performance. So when you're starting from scratch, building a taxonomy from the ground up, it's usually good to start with some good old-fashioned brain dumping, word mapping, just kind of getting it all out there on paper. Don't even think about computers at this point. Good old pen and paper. It gets you into a creative mindset, and it takes you down paths that you might not have considered before. And it's also even a really great way to begin visualizing a natural concept hierarchy. This previous slide is an example of some word mapping I did one time for furniture, and you can see how things just sort of branch off and you get to see all sorts of different avenues you could pursue for creating the concepts in your taxonomy. Depending upon the subject matter for your model use case and your familiarity with it, additional research may or may not be required. Often it is. And then the most important part of this taxonomy development is once you've got your list of concepts and you pretty much know what you want to build your model around, you need to establish ground truth for each of those concepts. In computer vision, ground truth is the mutual understanding of a concept based solely on visual criteria. The way data strategists establish the ground truth for a model is by creating what we like to call a visual dictionary. And in this visual dictionary, we define each concept with a wide array of visual examples. It's recommended to also include a text description, kind of just like talk about as much of the visual importances as much as you can, but the visual examples are the most critical. Also, the more nuanced your concepts are, the more visual examples you should provide. Finally, the most important thing once you have all of your concepts that you've decided will make up your taxonomy is to establish ground truth for each of those concepts. In computer vision, ground truth is the mutual understanding of a concept based solely on visual criteria. The way data strategists establish ground truth is by creating what we call a visual dictionary. In this visual dictionary, we define each concept with a wide array of visual examples. I also recommend including a text description of each concept, but the visual example is the most critical piece. And the more nuanced your concepts are, the more visual examples you should provide. Establishing ground truth provides basically visual confirmation that everyone involved in the project understands the taxonomy and concepts that make up the model's worldview. Also, if you need to get your data labeled by a label team, then this visual dictionary will become the basis for your labeling criteria as well. So it's also helpful to have that for that purpose. So I'd like to take a moment here to sort of walk you through more of the thought processes behind taxonomy development, just so you can get an idea of like what goes into it, like behind the scenes. So for a minute, we're just going to all pretend that we're data strategists, and we're going to be working toward building a furniture model to classify your average household furniture types. Considering there's lots of types of furniture, and we don't want to make a taxonomy for the whole thing, let's just think about one concept for now. Chair. So how many types of chairs can you think of right off the bat? How many types of chairs possibly exist in the world that you're unaware of? How much research is needed to gain a worldview of your understanding of what a chair looks like and a model's understanding of what all chairs could look like? Do you want to recognize chairs as one generic concept, or do you want to be able to recognize specific types of chairs for your models? So this is all dependent on use case. And then you start researching more and more, and you think, wow, there are so many types of chairs out there. And you look and you do even more subject matter research, and there's probably things you didn't even consider all over the place. All right, so which type of chairs are so visually similar that they should be combined into one concept? Or, if we create a generic single concept for chairs, how many types of chairs do I need to collect or create data for so that we're able to provide enough diverse examples for that one generic chair concept? These are just some of the questions that you'll consider while you're thinking about one model concept. And then you kind of repeat the process over and over again for all the different types of furniture until you've completed your furniture taxonomy to fulfill your use case. And here we have an example, part of an example of a visual dictionary. This is one that I created for a uniform project that our label force was working on. And you can see that I provided both a text description and multiple visual examples. Depending upon the use case, again, and the complexity of your taxonomy, your definition, your written definition, or your visual examples may be longer or contain more examples. It just, again, depends upon the complexity. So now that we've established our taxonomy, we kind of want to get into data curation according to our established taxonomy. As mentioned earlier, always keep in mind that your training data should match your model use case. It bears repeating just because it's critical to your model's success. Data strategists at Clarifai work with our customers to access and curate and optimize the best training data for their custom model building. So if you're doing this on your own, that's exactly what you'll be doing as well. This can include wrangling, cleaning, labeling, validating, constant bias awareness, and also setting aside a representative evaluation set, which is a subset of the data that will not be included in your model training in order to evaluate your finished model after training. So throughout all of this curative process, you'll usually perform some parts or combination of these curative steps, and I'll elaborate a little more into them. So wrangling data is essentially getting all of your training data, munging it all together from all its different sources and getting it into one app. Cleaning the data involves visually exploring a data set in Clarifai's easy-to-use platform and deleting noise, which are images that either don't align with the ground truth or they're duplicates. Sometimes you may be able to reuse imagery for another model or a different concept. Sometimes you just don't need it at all, and that's when you just remove it. And that's what we call cleaning. In the GIF on the right here, you can see an example of me manually exploring a data set for chairs and removing any of the images that don't fit with my use case. The easiest way I've found to begin removing noise from a data set is to use our Visualist Search and Explorer to locate large groups of visually similar images for bulk removal. Other steps that could be done in the curative process includes validating data, which basically means that you're confirming pre-labeled data is labeled correctly. You'll also work on labeling or annotating data, which refers to applying a concept to an input and therefore establishing your ground truth to ensure that each party agrees on what to label and how to label it is very important. And then also it's just very important to assess potential bias at all times and be aware of it and try to avoid it. Very much seriously, please try to avoid bias. Yeah, while curating data, it's just imperative to be constantly alert for bias. It occurs either when the scope of your training data is too narrow and not diverse enough, but it can also occur due to personal bias. It can affect the model from taxonomy development and onward throughout the data curation and labeling. And the best way to prevent biases from appearing in models is through rigor and unrelenting commitment to being independent and unbiased in your conduct. You have to constantly be aware. So it's important to stay mindful. In this example right here, we searched Google Images for Apple, and the results are predominantly, as you can see, red apples. But we know that there are green apples and yellow apples and many gradients in between. And if we built a model that only saw red apples, it would assume that all apples were red. And if you showed it a green or yellow apple, it might see the apple shape and think it's an apple, but it might also be confused because you only told it apples are red. So it sees a green or yellow one and it gets confused and assume it might be another kind of fruit. So again, very important to just make sure you create that whole world concept, make your training data as diverse as possible. So you've made your taxonomy, you've curated your data set, you're ready to go for model training. train V1 of your model, and then evaluate it on the platform, which will help you gain a baseline understanding of your model's performance. Context-based classifier models will usually train within a day as long as there's less than 1 million inputs. Deep training ETA is a little more of a black box depending upon the amount of data, but it generally takes longer than context-based classifiers. So this page right here is showing you the versions page of Explorer. And here you can track your different versions of your model and view its corresponding evaluation metrics. You can track your model's performance as you continually make adjustments to the data or taxonomy in your quest for peak performance. And then we use evaluation metrics to assess like current model performance and then also check for kind of weak points. And my favorite tool is the concept matrix. It's an easy visual way to evaluate how your model is performing. It summarizes how successful a model's predictions were by illustrating the correlation between the concepts and the model's classifications. So a well-built model will have a strong, solid diagonal line going from left to right. Concepts that co-occur or are similar may appear in kind of clusters in the matrix, but that doesn't necessarily indicate something wrong. In the example I've shown here in this concept matrix, this is for a model we have that we offer called room types. And there's a cluster area you can see near the middle. And this cluster area reveals that fireplace and living room are occasionally being confused for one another in the model predictions. However, I'm not concerned about this as a strategist, data strategist, because I understand that fireplaces are most commonly found in living rooms. And so much of the fireplace training data must have also contained context that made it look like a living room. If the cluster had, say, confused concepts like hot tub and bedroom, that's when I would have far more concern, do a deep dive into my training data, because those are things that are so visually different, they should not be confused. But when you have like an area of slight confusion between things that overlap visually, you don't need to be as concerned. So with help from the eval metrics, you can make adjustments to your model to improve performance. You can reshape your taxonomy by adding, subtracting, or combining concepts. You can strengthen poor performing concepts by adding more data. But again, be careful not to imbalance your concepts. If you have one concept with 100 training inputs and then another with 10,000 training inputs, it will create a bias in your model. So after you've built your model, and you're using it and release it out into the wild, is what I like to call it. There's just a few things to be mindful of after you deploy that model. Be mindful of data drift first and foremost. Data drift is also known as model drift, concept drift, or model decay. This refers to the degradation of a model's prediction power due to changes in the environment. So in other words, as time goes by, the data in the data that your model sees will change, but we don't know how much it will change. So we need to be on a lookout for such changes and then be able to collect new data to then refit that model and retrain it. We have a tool called Collectors, which will help you turn that on for your model and start collecting data all the time so that you can then use that data for your retrainings and make sure that you're upkeeping with data drift. Another thing is just, I'd like to stress that there is no perfect model. As long as it's suiting your needs, that's awesome. However, you could probably work on a model forever and ever and ever, keep refining it constantly, you know, adding little bits of data here and there. But there is no perfect model. You know when it fits your purposes. And just don't forget to schedule model retrainings, because it's very important to just make sure that your model is kept up to date with the data. And yeah, you should be good to go. So with that, I just wanted to thank everybody for tuning in and listening to the model building process and like details in the taxonomy. And yeah, thank you everyone so much.
Thank you so much, Karen. It was a pleasure. A big round of applause from our virtual audience. We will see you at our next session.